Hey everybody, welcome to the exciting conclusion of the review of 5-1 operations with polynomials. So what we're going to do quickly is we are going to examine four expressions and determine whether or not they're a polynomial. If they're a polynomial, we're then also going to state the degree. If you'll notice over here, what I have is a list of things that make an expression not a polynomial, and also how to calculate the degree if in fact we're dealing with a polynomial. So in number one, if we look at the expression, we can see that none of the items over here or this list here applies to the expression that we're dealing with at the moment. So immediately we're able to state that yes, this expression is in fact a polynomial. And in order to determine the degree, we're going to look at each of the two terms. We can see that in this term, the degree of this term is 5. However, in the leading term, we have two variables. When you have two variables or more in a term, what you do is you add the exponents together. So because the degree of the first term is 7 and the degree of the second term is 5, we take the largest exponent, and so we would say that the degree of that particular polynomial is 7. Moving on to number 2. First, we're going to determine whether or not it is a polynomial. As you can see, one of the things that polynomials cannot have are roots of variables. So immediately, this square root of x makes this expression not a polynomial. Moving on to number 3, we can quickly observe that we do have variables that contain negative exponents, and so that would make the third expression also not a polynomial. Moving on to the last example. The last example I put in here because students often get in their head that you cannot have a fraction in order for something to be a polynomial, and that's not true. The only thing that you cannot have is a variable in the denominator. And as you can clearly see here, right, this is not a variable in the denominator. And so this expression is a polynomial. So yes, it is a polynomial. And we have a term that is of degree 2. And we have a term that is of degree 8, which gives this polynomial a degree of 8. Moving on, we are just going to perform a little bit of basic addition and multiplication with polynomials. So in number 1, we have this polynomial being subtracted by this polynomial. When you have subtraction, what you're going to want to do first is distribute the negative or distribute the subtraction, which will leave us with the following expression. Remember that when you distribute that negative, it is going to change the signs of every term. At this point, all we're going to do next is combine like terms. So we will combine the 4x squared with the minus 2x squared, which gives us 2x squared. We are going to combine negative 5x along with the minus 3x. Negative 5 minus 3 is equal to negative 8. And lastly, we'll combine 6 and 1, giving us 7. Number 2 is served to be a reminder to pay attention to what the operation is between the parentheses. Here we see addition. When there's addition between the parentheses, you can go straight to combining your like terms because with addition, we're not going to have any signs change. So we are going to combine 6x squared and negative 4x squared, which will give us 2x squared. We'll then combine negative 7x and positive 9x, giving us positive 2x. And lastly, we're going to combine the 8 and the minus 5, which will give us 3, which will give us a final answer of 2x squared plus 2x plus 3. Lastly, we're going to multiply these two expressions together. One way to approach this is simply by taking each term in your first set of parentheses and distributing them to each term in the second set of parentheses, which is going to give me here 4n times n is 4n squared. 4n multiplied by 2 is 8n. And lastly, we're distributing this negative 6 to n, giving us negative 6n, and negative 6 multiplied by 2, giving us negative 12. The last thing we have to do is to combine like terms. Upon doing that, we should get an answer of n cubed plus 6n squared plus 2n minus 12. That's it for now.